A robotic arm has a joint control loop transfer function of GC of S, G of S equal to 300 multiplied by S plus 100 upon S multiplied by S plus 10 multiplied by S plus 40. Prove that the frequency equals 28.3 radians per second when the phase angle is minus 180. Find the magnitude at that frequency. Let us consider the Bode plot of this system. This is the, let us assume that this is the magnitude plot, and this is the phase plot. This is magnitude plot. This is dB versus log omega. And this is a degree versus angle, degree versus log omega. At minus 180 degree, it cuts the phase plot. This is phase plot. Here, the frequency at this point is called omega PC, phase crossover frequency. That is given because it is given that it is 180 degree. Phase crossover frequency equal to 28.3 radians per second. That is given. We would prove that 28.3 is correct. That is one thing. The second part is find the magnitude at that frequency. So draw a vertical line at that point where it cuts the magnitude plot. Find the magnitude at that point. That is the second part of the question. First part is GC of j omega, G of j omega equal to 300 j omega plus 100 upon replace S by j omega. J omega plus 100, j omega plus 40. So this angle of GC of j omega, G of j omega at omega equal to omega PC, that is omega equal to 28.3 equal to minus 180, we have to prove. So what is the angle of G of j omega? That is angle of 300 is 0. That's why we can left. Therefore, plus tan inverse of omega by 100 minus angle of j omega is 90 minus angle of j omega plus 100 is tan inverse of omega by 10. This is 10 minus tan inverse of omega by 40. At omega equal to 28.3 equal to what we have to find, that must be equal to minus 180 degree. To find that, substitute omega equal 28.3, you will get this is equal to plus 15.8 minus 90 degree minus 70.5 degree minus 35.3 degree equal to, if you add these two, 105 minus 105.8, so 15.8, if you subtract minus 90, so minus 180. Therefore, 28.3 is correct. We proved. First part is over. Prove that the frequency equals 28.3 when the phase angle is 180. So we are getting 180 degree. This is equal to 180 degree we are getting. Hence it is proved. Find the magnitude. To find magnitude, we have to find magnitude of this. That is equal to what? 20 log 300 j omega plus 100 upon j omega plus 10, j omega plus 40. That is equal to 20 log 300 plus 20 log square root of omega square plus 100 square minus 20 log omega minus 20 log square root of omega square plus 10 square minus 20 log square root of omega square plus 40 square. If you substitute all these values, what you will get is so 20 log 300 equal to 49.5 plus this is at to omega equal to 28.3. You have to substitute omega is 28.3. So you will get 80.02 minus 29.03 minus 42.16 minus 64.23 equal to 5.67 minus 5.67. Therefore, the magnitude at this point is minus 5.67. That is the answer. dB minus 5.67 dB. Sometimes the examiner may be asked you to find the gain margin. Gain margin equal to what? Minus of minus magnitude at omega PC. At omega PC, magnitude is 5.67. Therefore, minus of minus 5.67 equal to 5.67 dB. That is the gain margin. Phase margin. Phase margin is phase margin equal to when magnitude equal to 0 dB, we have to find the angle. It never crosses 0 dB. Therefore, phase margin equal to infinity. That's all.